Hey guys, so we're going to take a look at your data booklet. If you want to take it out and turn to page 6, you're going to see this chart titled an acid-base indicator chart. And all this really is this is a chart that kind of explains or gives a bit of information of certain chemicals that we can mix in with acids or bases, and they will give a particular color to indicate a roundabout pH range of that particular solution. So so that I can explain how this chart kind of works, what I'm going to do is just kind of go through a couple of, just one hypothetical scenario of if we were to mix any one of these indicators with hydrochloric acid. We know that hydrochloric acid is a strong acid, and so it's going to have a really, really low pH. Let's say that this particular solution has a pH of 1.0. So if I were to take, for example, this indicator called methyl orange, I know that over here the pH range of methyl orange is 3.2 to 4.4. And what this means is that any solution that methyl orange is put in that has a pH of less than 3.2, it's going to have a red color. And any solution that I stick methyl orange into that has a pH of greater than 4.4, it's going to have a yellow color. And so if I were to stick this indicator, methyl orange, into hydrochloric acid, which has a pH of, in this case, 1.0, then I know that that pH is less than 3.2, so methyl orange is going to give me a red color. And these colors correspond to what type of methyl orange molecule is going to be in that solution. Now, the chemistry behind it and the reactions that occur, you don't really need to know until Chem 30. But all you need to really know is that if I have red in the solution, then I'm going to have the methyl orange that is a chemical formula of HMO. And all this means is that this is a methyl orange molecule with a hydrogen attached to it. If I put methyl orange into a solution that has a pH of greater than 4.4, then it's going to give me a yellow color, which means I'm going to have MO- molecules there. And that's all you really need to know about that. We can have some solutions that are maybe end up in the middle of the range. So let's say that we have some unknown solution that has a pH of 3.7. Well, that's in between 3.2 and 4.4. So all that really is going to mean is that I'm going to have a little bit of red and a little bit of yellow mixed in. And so I should see an orange color for that solution. Because a little bit of red mixed with a little bit of yellow is going to give me orange. And that's really it. You could do this with any indicator. You could do this with bromothiamyl blue or phenolphthalein, and these are some indicators that we have. And if you stick with me here in the next clip, I'm going to do a little bit of a demo with you of some of these different indicators tested in solutions so that you can kind of see these color changes and how they occur. One last thing that you don't need to know is you can see on this chart here we have this last column called Ka. This is Chem 30 stuff. You don't need to know this. I just have it here in your Chem 20 data booklet because this is the exact same acid-base indicator table that you'll get in your Chem 30 data booklet. So I just kind of copied and pasted it into here so that it was the same and it wasn't any different from year to year. So that's it. Stick with me, guys. I'll be right back with a couple of demos. Okay, so I wanted to do a little demo for you guys. Now that we've learned how to use the data booklet and the chart in there, I want to just kind of demo what it is that we see in the chart so that you can sort of link real life stuff to what's in the data booklet. So here is just a real small, you can see a very small amount of hydrochloric acid in the solution. And what I've added to this solution already is I've added an indicator called phenolphthalein. So it has the symbol HPH, capital H, capital P, lowercase h. So you can pause the video and go ahead and find that in your data booklet, and when you're ready to go you can hit play again. So inside of here you can see that phenolphthalein yields a colorless color. There's no color to it. And the data booklet tells us that when phenolphthalein is a colorless color, that this solution is going to have a pH of less than 8.2. And this makes sense, right? We know that this is hydrochloric acid, and so putting HPH into here, or phenolphthalein, we know that this would give us a colorless color because, hey, we know that hydrochloric acid is an acid and that's going to have a pH of definitely less than 8.2. But if I add a base to this and change the pH so that it starts to increase, if I can add enough base to this to where the pH now is going to be higher than 8.2, then we should start to see that pink color that the data booklet says phenolphthalein is going to have in a solution that is greater than 10.0. So, go ahead and add this base to this, and you can see that as I add some base to this, it's going to change the color. And I can take some acid and lower the pH again. Oh, there it went, disappeared. So the reason it does that is because sometimes not all of the base has reacted with the acid. And so when the base finally all reacts with the acid, there's no more base left in the solution. And so then it goes back to colorless because the pH of this is still less than 8.2. So if I go ahead and add a little bit more base to this, then you can see maybe just a little bit more is going to drive this above 10.0, and that's going to stay a pink color. Now I can add a little bit of acid to this, drop the pH back down below 8.2, and I should get that colorless color again. So that's sort of a visual so you can see kind of how these indicators work. They can kind of jump back and forth between their colors depending on what the pH of the solution is. Now, I've got an example here of a solution, an unknown solution. We'll call it solution X. And it's poured into 3 different beakers. Each beaker is tested with a different type of indicator. And I've indicated what the acid-base indicators are here that are used in each of these 3 beakers. And in fact, I've got them right here. So you can see this is solution X. And inside of this beaker, I've tested solution X with methyl orange. And methyl orange turns out to be a yellow color. So you can go ahead and write yellow in there in your notes. If you're copying this down, it'd be a good idea. This is yellow. I can take same solution, solution X, and I can test it with methyl red. And so methyl red ends up being a red color. I know it kind of looks pink, but this is the red of methyl red. And so then we can write that information down for that one. And then this is, again, solution X, but tested this time with bromothiamyl blue. And bromothiamyl blue, you can see here, is yellow. And so those are the colors. Now what you can do with this is you can indicate what these colors are. Yellow, red, and yellow. And then go ahead into your data booklet on page 6, and you can identify now what is the pH of this solution. Well, we know that methyl orange, when it's yellow, that solution is going to have a pH of greater than 4.4. And that's all the information methyl orange gives us. But if we use this same solution and test it with other indicators, we can kind of whittle that down to a pretty small pH range. You can see the bromothiamyl blue over here is yellow, and this tells us that the pH is going to be less than 6.0. And then methyl red, giving us a red color, is going to tell us that that pH is also going to be less than, or not also less, but it's going to be less than 4.4. And so you can now look at this information and you can say, okay, well, I know that the pH is less than 6.0, but because I tested it with methyl red, I also know that it's less than 4.4. So I know it isn't higher than, say, 4.4 or 5 or whatever. I know it's less than this number, so this information now kind of becomes a little obsolete. But I can see here, sorry, this should be 4.8. I can see here now that my range for this solution, solution X, is going to have a pH range of somewhere between 4.4 to 4.8. And so this just kind of helps us with our understanding of how acid-base indicators are used, and gives us a better understanding of how we can take an unknown solution and identify its pH to a pretty accurate level if we have enough indicators that we can test that solution with. And that's it for this one, guys. Thanks for watching.